Today's lesson is on verifying trigonometric identities. Verifying trig identities is transforming one side of a trig equation into the form of the other using two big things. First, the basic trig identities. So those are the identities on our sheet that we filled out yesterday. So these guys here. And good old algebra. So these can be very simple or they can get very complicated. So what I'm going to go through are some tips and some strategies that you can use in order to solve these problems. First is you're going to pick a side, and the side that you should pick is the more complicated side. So transform the more complicated side into the form of the simpler one. Second is to express all trig functions in terms of sine and cosine. So there are 6 trig functions, and then tangent, cotangent, secant, and cosecant you can rewrite in terms of sine and cosine. When you express everything in terms of sine and cosine, you're going to end up with a lot of fractions. So a big thing that we're going to do a lot is find common denominators. Next, you're either going to factor, factoring is going to be a big thing, or multiply in order to simplify the expression. Sometimes you're going to need to force the issue. So we can do that by multiplying by 1. So we can introduce things into the problem by multiplying by what I call a fancy 1. Keep an eye on what you're trying to get. If you're trying to get a tangent, then try to make that happen. And this will all make more sense once we get some examples. The last one is be neat, because if you drop a negative or a squared or something like that, then you're not going to end up with the correct solution. And I'm going to require that you work these problems vertically. So these are all the things that you should do in order to verify these trig identities. Next thing I'm going to talk about what you should not do. So do not add, subtract, multiply, or divide on both sides of an unverified identity. This is using the properties of equality. So when you're solving an equation, you can add 2 to both sides of an equation or subtract 10. But in an unverified identity, we cannot do that. So you can't just multiply by sign to get rid of things in these identities. So now we're just going to do a bunch of examples. So we're going to verify. This first one is secant squared x minus tangent of x cotangent of x is equal to tangent squared x. So the first thing you need to do is decide which of these sides is the simpler one, or the more complicated one, because that's typically the one that's going to be the easiest to transform. So in this case, that means we're going to transform this side. The next step is to turn everything in terms of sine and cosine. So secant squared is going to be 1 over cosine squared. Tangent is going to be sine over cosine. Cotangent is going to be cosine over sine. Now you might start thinking it's tedious to do the x or theta every time, but you should do that because trig functions are trig functions of something, so we need the of something. Well, if you look here, if we multiply these together, we'd have sine cosine over cosine sine. So those all cancel. So that whole expression is now going to be 1. So we have 1 over cosine squared minus 1. Okay, so now we get to this point where I'm trying to get this to equal tangent squared. Okay, well I can do that by getting a common denominator. So I'm going to replace this with cosine squared x over cosine squared x. So that's now 1 minus cosine squared over cosine squared. 1 minus cosine squared, and the more we do these, the more you will just automatically see that's equal to sine squared. And what do you know? What is sine squared over cosine squared? That is tangent squared. Okay, which is what we were trying to get. So that's the process. You pick which side is more complicated, turn everything in terms of sine and cosine, and just keep simplifying with the eye on where you're trying to get. Okay, so here's our next one. Step 1, which side is more complicated? That's going to be this side. Then we're going to turn everything in terms of sine and cosine. So we're going to have 1 plus sine squared over cosine squared all over 1 over sine times 1 over cosine. Okay, in the numerator, I'm going to get a common denominator. So that's going to make this cosine squared over cosine squared. So I'm just going to go ahead and do that in my head and combine. So cosine squared over cosine squared plus sine squared. We're going to have cosine squared x plus sine squared x over that cosine squared all over 1 over sine of x cosine of x. Okay, so we have this whole big thing, and you can see how being neat is going to be really, really important here. Okay, I'm going to do two things here. First, cosine squared plus sine squared is just 1. And then rather than having this big old stacked fraction, I'm going to take this and then multiply by the reciprocal here. So that's going to be times sine of x cosine of x over 1. Well, the cosine on the top and the cosine on the bottom, since we're multiplying, we have a cosine and a cosine squared. So that's just going to reduce to cosine, which leaves us with sine over cosine, which is tangent, which is what we were trying to show. Okay, here's our next one. So we have cosecant of x minus cotangent of x, all of that squared, equals 1 minus cosine over 1 plus cosine of x. So first I'm going to choose which side, and there's going to be more things to do here. So that's the side I'm going to pick. Turn everything in terms of sine and cosine. Okay, I do have a common denominator. So this will be 1 minus cosine of x over sine of x squared. Okay, so keeping an eye on what I'm trying to get here, I'm trying to get a 1 minus cosine over 1 plus cosine. So I'm going to take this and I'm going to rewrite it as 1 minus cosine of x times 1 minus cosine of x, because that would be equivalent to 1 minus cosine squared. And then in the denominator, that's going to be sine squared x. Keeping an eye on what I'm trying to get everything in terms of sine and cosine. So I'm going to take this sine squared and replace it with 1 minus cosine squared. Okay, we're trying to get 1 plus cosine, and this will happen a lot in these, where we're gonna factor, and this is really the difference of two perfect squares. So that's gonna factor. I'll rewrite the numerator there. The difference of two perfect squares is gonna be 1 minus cosine of x times 1 plus cosine of x. Okay, well then it's pretty straightforward what we're going to do here. We've got a 1 minus cosine in both the top and the bottom, so we can eliminate those. which leaves me with what we are trying to get, 1 minus cosine over 1 plus cosine. So let's write that down. And we have verified that this is equal to this. So our next example, we have sine of x over 1 plus cosine plus 1 plus cosine over sine. So what we're going to do here is get a common denominator. I'm going to multiply this side here by sine over sine. And I'm going to multiply this side here by 1 plus cosine of x over 1 plus cosine of x. And you can write this in the next step. I'm just going to do it there. So here we're going to have a sine squared x. My denominator is going to be sine of x times 1 plus cosine of x. Here we're going to have 1 plus cosine of x, 1 plus cosine of x over sine x, 1 plus cosine of x. Now we can distribute the sine through, but I'm not going to, simply because I know I'm trying to get to cosecant, which is 1 over sine. So I'm going to leave this sine here, hoping that eventually I'll be able to get rid of the 1 plus cosine. So I'm going to combine these and FOIL this. So we're going to have sine squared x plus, when we FOIL this, 1 plus, so we've got 1 cosine plus cosine is going to be 2 cosine of x plus a cosine squared x. All right, well, sine squared plus cosine squared, oh, sorry, denominator. And that'll happen, you'll start seeing things and you want to jump to it, but make sure you're copying everything down. So here, sine squared plus cosine squared is just going to equal 1. So we're going to have 1 plus 1, that one, plus 2 cosine of x over sine of x, 1 plus cosine of x. Well, 1 plus 1 is 2. Okay, another, again, big thing that we're going to use over and over and over again is factoring out factoring. So here I'm going to factor out a 2, which leaves me with 1 plus cosine of x, which is good news. Well, the 1 plus cosine over the 1 plus cosine is going to reduce. So I'm left with 2 over sine, which is equal to 2 cosecant of x. Okay. This next one I'm going to show you in 2 different ways. I'm actually going to work both sides of the equation to show you that you can do different sides based on how you approach the problem. First, I'm going to do the cosine to the 4th problem, and for that I want you to consider what this would look like if you didn't have the cosines, if it was just x. So that would look something like this, x to the 4th minus 2x squared plus 1. Well, the key here is going to be factoring, and if I factored this, we're looking for 2 things that multiply to get x to the 4th. That's going to be x squared and x squared. And then 2 things that multiply to get positive 1 but add up to get a negative 2 would be minus 1, minus 1. We're going to do that same thing just with cosine. So this is now going to be cosine squared x minus 1 times cosine squared x minus 1. Well, we're trying to get sine, and we sort of have that. 1 minus cosine squared equals sine squared. So if it's switched like this, this is going to equal negative sine squared. but in the end, a negative times a negative is going to be positive. So negative sine squared times negative sine squared is going to be a positive sine to the fourth. Okay, so that's working that side using factoring, but maybe factoring just isn't your thing. You're not great at it, and avoid it when you can. Well, in this case, we can. I'm going to work this side. And this side I'm going to approach with the idea of I'm trying to get this, which involves entirely cosines. So I can rewrite this sine to the fourth as sine squared times sine squared. And once I have a sine squared, I can turn that into 1 minus cosine squared. And then I can simply just FOIL, and foiling is easier to do than factoring. So 1 times 1 is 1, 1 times negative cosine plus 1 times negative cosine is negative 2 cosine squared. And then negative cosine squared times a negative cosine squared is going to be a positive cosine to the fourth x, which is what we have here, just in a different order. So you don't always have to pick one side over the other. You can typically take the simpler side and turn it into the more complicated side if you just think about where you're headed. Okay, this will be my final example. We have cosine over 1 minus sine equals 1 plus sine over cosine. Well, let's go through our process. First step is to pick the more complicated side. But in this case, these are pretty equal. Second thing we can do, so we'll just arbitrarily, I'll just pick this right side. Then we turn everything in terms of sine and cosine. And we're done. So this one's a little bit tricky because there's not a lot of simplifying, there's not a whole lot we can do here. So this is going to be what I'm going to call force the issue. I'm going to force one of these sides to look like the other side. So I'm going to pick this side, and if I want it to look like this side, that means I need a 1 minus sign in the denominator. So let's just put a 1 minus sign in the denominator. But if we do that, in order to not change the problem, we're going to also have to put one in the numerator. So we're multiplying by our fancy 1. This is my fancy 1. In the numerator, I'm going to FOIL. So 1 times 1 is 1. Then we have a minus sign and a plus sign, so those will cancel. And then we have sine minus sine times a negative sign is sine squared. And you could distribute this here, but I purposely put this 1 minus sign there because I want it in the answer. So I'm going to take cosine of x and multiply it there, not foiling because I'm hoping that that cosine is going to go away. Well, how is that cosine going to go away? Well, because 1 minus sine is cosine squared. And then cosine squared divided by cosine is going to reduce. So we'll have just one cosine in the top. And in the bottom, 1 minus sine. So this is, like I said, my method of forcing the issue. I want a 1 minus sine there, so let's put that. Here we could have multiplied by cosine over cosine, and we would have ended up with a similar result. So that is verifying trig identities. These take practice. They take just knowing those identities. The better you are with algebra, the easier these are going to be for you. So now it's time to practice.